Welcome to the Mohawk WiTTConnect Tech Talk. We are just going to give people a few more minutes to be added in to our wonderful session this afternoon. Just a heads up to everybody, this session is being recorded. I think maybe I'll just give it another few seconds. So thank you everybody for joining us this afternoon. My name is Rebecca Isawa. I am the program manager in continuing education here at Mohawk College, and I take care of the technology and skills portfolio. I'm also one of the founding, steering committee members of our Women in Technology and Trades group that was reformed a few years ago here at the college. This is a group that is designed to provide awareness, support, mentorship, and connections for people thinking about careers they might not have thought of. So this is more to support underrepresentation of women specifically in the careers of the fields of technology and trades. So this part of our offering, we do a number of different things throughout the year. Part of our offering is what you're about to join us for this afternoon. We have established a series, what we call them our WiTTConnect Tech Talks. And the Tech Talk this afternoon is all about artificial intelligence. Throughout this session, which I will do an introduction to our wonderful speaker in just a second, but just a few housekeeping items. We will have time for questions at the end. But if anybody wishes to has a question during the session, please do not hesitate in utilizing that chat box. The chat box at the bottom. We'll be monitoring your questions and we will be addressing them either throughout the session or we will be happy to take them up at the end. So unless anybody has any questions right now, what I would like to do is introduce Minnie Thomas. So everybody, welcome Minnie, and thank you so much for joining us. To everybody, Minnie is one of our wonderful faculty members here at the college. Minnie's in the School of Engineering Technology, specifically electrotechnology, and she is one of the faculty that is working on our brand new digital health program. Minnie has expertise in human-machine interfacing, robotics, and artificial intelligence. And she is also in the process of completing her PhD. With that, I would love to turn this over to Minnie. And again, Minnie, thank you so much for putting this on for us this afternoon.
Thank you so much, Rebecca, for that introduction. And I'll just share my screen before I start. You all can see my screen and hear me? Perfect. Thank you, everyone. Thank you for coming. Thank you, Rebecca, for that wonderful introduction. I really appreciate this time from the WiTTConnect Tech Talk for inviting me to present this artificial intelligence. And I'm so excited to present because while I was preparing this presentation and while I was actually preparing everything, I was just going through the whole process of how beautiful this whole topic of artificial intelligence really is. So I would, before I really dive into the topic, I want to introduce myself, as most of you know, and my name is Minnie Thomas. I'm the professor in electrical engineering, as Rebecca just said. I'm also a researcher in MEDIC, involved with multiple researchers in M.Eng and E.L. and currently I'm doing the PhD in software engineering at McMaster. Okay, so before I dive into AI, I would like to talk a little bit on my journey with technology so far. Actually, my journey with technology started when I was very young and around 10 years. Maybe I was 10 years old, and that was as an assistant to my dad. My dad was an electrical major and a chief technical officer in a very busy zone in railways in Bombay, India. And at home, I was his assistant in wiring, repairing, installations, etc. So when my sisters, we are three sisters, when my sisters felt medicine or commerce was the best for women, I persisted that I wanted to become an engineer like my dad. Okay, so that's how my journey started. The journey I started as an apprentice to my dad continues, and the journey is on. I am a professional engineer and I've completed my master's in electrical engineering. I started as a lecturer. So some of the pictures I've put here are just giving me as is my flashback of my journey as in my professional career. So when I joined as a lecturer, I was into a program which was new, developing new courses and course curriculum, got married, became the mother of twin boys, and then we moved to the Middle East, to Qatar. I'm not sure, most of you must be knowing or may have heard, but then I took up the role in Qatar as an instructor in a university, and some of the pictures here are showing the graduation picture of our students, and a very active, vibrant picture of the female students. So there in Qatar, we used to have separate, so it was not mixed. The boys and the males and the females would be separate. So this was a picture which they actually gave me a party when I was actually leaving Qatar to come to Canada. I was actively involved with the students, and I was the one who was instrumental in establishing the IEEE, the first IEEE student chapter for the women, and for the whole department. And then the journey continued. I was also involved in research. And this is one part of me where which keeps me to keep on learning. And some of the researchers, not all the pictures I don't have, but some of the researchers that I was involved in are the Shell Eco Marathon. You can see that. So this was just before I left the university. We had participated in the electric prototype car, we won the second place, and I was involved in that team. Was also involved with multiple other research, especially with biosignals for neonatals, using machine learning and SPM models in MATLAB. And so we were involved in a research with the Queen's University of Technology, Brisbane, Australia, focusing on advanced signal processing for machine learning on cardiovascular and EEG signals. That continued, and then I moved on and came here to Canada with my family, and I just started as a technical coordinator in an industry, and then joined Mohawk College about 4 years before as a coordinator first, and then now I'm the professor in the electrical and computer engineering technology. I got the opportunity to actually learn more and get trained with the robotics here at Mohawk. And I'm really thankful to Mohawk for that. And so I got trainings, and then I took some tests and certifications, and I'm one of the FANUC certified instructor in the campus. So I was also involved in researches here in Canada at Mohawk for developing a seizure detection tool. And some of the pictures here are how this work helped me to present this in different places, like the Innovation Nation conference in 2019, was also invited at the IEEE conference. And the students who helped me here are, the picture shows the students who worked with me in the project. And this journey, which I started when I was 10 years old, still continues. I am doing, I'm learning every day, actually. Every day is, I'm learning. When I teach my students, I learn, and I am learning as a student. So currently, while doing my PhD, at McMaster, I have got the opportunity to work on some really good projects, including my thesis, which is going on. So I've been working with a content management system for a CPR, the Cardiopulmonary Resuscitation. This is a global initiative by McMaster, and we as a team were instrumental in developing a basic content management system for the CPR. And my work continues in the area of autonomous medical advisory system, how trust, especially in the area of security, privacy, and trust for AI and autonomous systems, in especially focusing just on the medical systems. That's in short about me. And many of you who are listening to me must have heard about AI in different contexts. Maybe as in a sci-fi film, or everyday news, or chatbots, or self-driving cars, or medical imaging, maybe warehouse, so many different, it's everywhere actually. AI is one of the top emerging technology. And before I talk about AI per se, I would like to just give a context of the emerging technologies. According to the 2020 emerging technology presented by CompTIA technology community, AI is rated as the first top of the emerging technology, followed by 5G, which is going to be highly improving on latency and intelligent power consumption. Then the IoT we all know about, serverless computing, biometrics, AR, VR, we heard last time in the Connect talk from Madeline about it, and then the blockchain, robotics, NLP, the natural language processing. And I believe what will revolutionize all this is the quantum computing. And this is just a list which is presented by CompTIA. I'm sure this list will be evolving, and it will be different every year. So there is a wide variance in opinion about AI. When I was asked about AI several years before, there were mixed questions. What is it all about? And there were views which were not all optimistic. There were different kinds of views about AI. But today, my intent is to provide a very holistic view about AI, to see what is its potential to reshape the world we are in now, and see its major boons to the various fields, and also see the challenges. Before I really jump into it, I would like to show a video. This is from NVIDIA Corporation, and it gives a beautiful narration about I am AI in just a couple of minutes.
I am an explorer. Searching for the origins of our universe. And charting a safer path to other worlds. I am a helper, moving us forward one step at a time, and giving voice to every emotion. I love you. I am a healer, modeling the future of medicine. And finding the needle in a haystack when every second counts. I am a visionary, uncovering masterpieces lost to the ages. And finding new adventures in a galaxy far, far away. I am a builder. Driving perfection in everything we create. I am even the narrator of the story you are watching. And the composer of the music. And when the world faces its greatest challenge, I give us the power to take it on together. I am AI.
Okay. So coming back to the PowerPoint, so that was a very short, brief introduction about AI. I like the video because it covered almost all the fields, and that is why I picked maybe that is a good way to start. So what is in it for me and in this journey of AI? So let us dive together to see where this journey actually began and how it is evolving now. If you look at this graph, which I've just put some milestones in the AI journey, very few of them, but the beginning of this journey is not just few years before. It was in 1950s. When the scientist Alan Turing, he spoke about AI back then, with the concept of machine being intelligent like man, like him. And he sowed the seed of what we are seeing today. So the Alan Turing theory is what is the foundation or the basic of which. And then it was dormant for a time, and in around 1980s, AI or the machine learning came up or sprang up, and we saw that in the classification in email, like spam filters or putting it in the spam folders. And then that was the era where we saw a little bit of AI work or the machine learning work done. And the whole world attention was caught in 1997 when the Deep Blue, designed by IBM, bet the chess grandmaster Garry Kasparov in 6-game series. I mean, this was the change. This was a big leap in the AI story. And then about 10 years before, the AI took another leap. And that happened here in Canada with a student called Alex Christway doing a computer science PhD program in AI in the University of Toronto. And he won the ImageNet competition. The competition was about evaluating so many images and making algorithm for object detection and classification. And he and his fellow and his team member, both of them, they decided to make use of AI to do that, and they won the competition. Like the margin was so high, it was about 12%. So there were the other competitors were far behind. Now, that was the major breakthrough. And since then, AI trajectory has been exponential. If you look here at the picture, it has been growing ever since. And the growth of AI keeps continuing. And there is a lot of research being done in AI. And some such work, which is also helped by different faculty and researchers around the world. Around 2012, there has been an exponential growth in computing, and that continues, especially in this COVID time. I was reading about how AI-based online screening and triage tool, helped the hotlines were getting jam-packed. So this tool could rapidly differentiate between those who might be really sick and those who may be suffering from less threatening ailments, and then offer, immediate care and attention to those people. This was built as early as April. So when the outbreak sprang up a bit between February and March, or everybody was alarmed, and they built this tool in Seattle, and then so many other, so it was built in partnership with Microsoft, and then so many others followed in with one very interesting paper finding which I read on what the AI-based tool was, how this tool was used in detecting the X-rays, and especially for COVID-19, the X-rays will present some abnormalities in the pulmonary area. And so with this kind of AI-based tool, what the researchers plan to do is they would make, they could detect what was the right time to put a COVID-19 patient on ventilators, just to optimize the ventilator usage and patient recovery, and so on. So there were AI chatbots, which were made for straightforward chat interface and AI. So what I'm saying is just about the season we are now, but we know AI, we just saw in the video that AI is used everywhere. So when I talk about AI, it is having two parts, the intelligence, which is artificial. So before we actually see what is artificial intelligence, I thought it is good to really understand the whole process of intelligence, because the theme of my talk is from human neurons to artificial neurons. So I thought of connecting it with the human intelligence. And the intelligence, as if we look into the Oxford Dictionary, it's a process of learning, understanding, and applying the knowledge. And we know this from our human experience. Think about when I was a child, and our parents must have taught us by looking into different pictures. Maybe it's a picture of a cat or a dog, and you see those pictures for several times. And then when a new picture of a cat is presented, okay, you identify, or we can identify it very easily. This type of learning, which involves learning from experience, comes very naturally to mankind. And this is with the human neurons. It has the ability of extensive ability. But what we are trying to do with artificial intelligence is to mimic this kind of learning, understanding, and using the knowledge concept which we have with the human intelligence inborn into machines, especially computers. When I teach my students, I say computers are basically, they don't understand what they are doing. So I call them dumb, because they just do what you program them to do. Even if they give out a result that, okay, the image is a cat, they don't know what is a cat. So that is the basic difference. But artificial intelligence is the capability of a machine to imitate intelligent human behavior through the process of learning, understanding, and using the knowledge. And in this process, we know one of the most important process is learning. Unless we learn, we cannot apply it. So how smart is AI? And what is the length at which AI has gone? Basically, to say that, we would have to look into the 3 different types of AI which is out there, which is called as the ANI, the artificial narrow intelligence, the AGI, the artificial general intelligence, and the ASI, which is the artificial super intelligence. The artificial narrow intelligence is also called as a weak AI, or the narrow AI. And this is the only type of artificial intelligence we have successfully realized to date. So what it is a narrow AI, which is goal-oriented, designed to perform singular tasks. It may be a facial recognition when you're in the airport or somewhere. It may be speech recognition. It may be voice assistance. It may be driving a car, autonomous vehicles, or whatever it is. They are programmed and taught and trained to do a single task. While these machines seem intelligent, they operate under a very narrow set of constraints and limitations, which is why this is called as a narrow AI. And they mimic or replicate human intelligence in that particular domain only. They do not have any other context, and they can only be made to think or do in that domain. Consider a speech or a language recognition of the Siri virtual assistant on iPhones. Like, they can only do that task, and they are programmed and taught for that part. Artificial general intelligence, also referred to as strong AI, is a concept of a machine with general intelligence that mimics human intelligence or behaviors, with the ability to learn and apply its intelligence to solve any problem. We are not there yet, but this is something which the researchers are trying hard to advance into with a set of cognitive abilities, and cognitive AI is the part which is coming up. So research are really working into this area of having intelligence on AI, which is a general intelligence, which is similar or mimicking human intelligence. ASI, the super intelligence, is a little very far off, and I think it's still hypothetical, and it's something beyond humans. It is where machines become self-aware and they perform or exceed beyond humans. We are not there yet at all. We are not even there in the AGI state, but this is something which basically how the AI is classified. So what I am trying to present in this talk is a very high level overview about the AI and walking you through as much as giving you a holistic view about what it is, how it is done, and things like that. So the AI era is what we are in, and AI designed to perform singular tasks are very intelligent, and they are not limited. There are limitations, but they are very intelligent, and they are powered by achievements in machine learning and deep learning. And that is where I'm going to head towards for the remaining of my talk. So these AI, which we hear and talk about, is actually a program that can learn, can understand, and can apply the knowledge. So these three words I'll keep on repeating because that's the process of the whole thing. Excuse me. So the process of learning is called as machine learning, which is a subset of AI. Algorithms whose performance improve as they are exposed to more and more data over time. They self-learn, and then the algorithms are built so that they can not only be learning, but they can also be tested. They can not only be trained, but also tested and evaluated. And there is another subset of that. That means, how do we do this? How do we make the machines learn? There are so many methods that we can make the machines learn. But one of the most famous, or I would say a method which has really crossed the expectations in efficiency is the deep learning method. It's a subset of machine learning, which is multi-layered neural networks. And that is the catch. So the neural network is based on a vast amount of data, but it is basically trying to mimic what a human neural system does. So taking you there into what it is and how the learning happens, and then we will be diving into what this neural network actually is and how does it really mimic or try to mimic the neural system of the human brain. So as we saw, data is something which has to be fed into an AI. For us as humans, when we were shown those pictures of something, maybe maybe a cat or a dog or something, we are getting that data through our senses. For the machines, we have to feed those data. Those data is what has to be fed. Those data can have different features, but then it goes through a process of abstraction and generalization of the data to come up with any evaluation or any feedback. So if you have a big set of data, that data needs, or it has to be abstracted. That means it involves the translation of the data into broader representations and concepts. And then those abstracted data are used to generalize and to draw inferences so that the learning and the understanding is done with the generalization. So if you have a lot of images of for example, one type of object, so the abstraction is categorized as, say, a cat. Now, this there may be different postures, different angles, different types, different features, which has to be then coming under the category and then generalized so that an evaluation that, okay, this object which you're showing me is a cat can be realized with the machine learning model. So with that, we know that machine learning is the is the core of the AI. That means that is the part where we are teaching or training the machines to learn. And traditionally, I'm not sure if some of you are in the computer science program, but traditionally for machines to or for programs to run, what we usually do is we will write a program, give some inputs to the program, and all the computations are done so that we get a result. That is a traditional programming method, and that is how we do programming, whether it is in Java, Python, or anything. But the machine learning is in a different way. We are actually feeding the output. That means I am giving the output and the data together, and the machine learns with this numerous number of data with the result which is already given, so that it is programmed to make a model which can be evaluated to find out, okay, is this object classified, recommended, or whatever is the objective of that model. So that is how machine learning is different from the traditional learning or traditional programming. Now, if you have to think about machine learning, there are so many different methods which you can use, but basically they are classified into just 3 categories: the supervised learning, the unsupervised learning, and the reinforced learning. The reinforcement learning is the newer machine learning technique in which the learning is kind of self-learning with a lot of reward points for every action the model takes. But basically, these are the 3 types of machine learning. And depending upon the algorithms you want to make, whether you use a regression or a classification method or a clustering method, it all depends. So I don't want to go into too much of detail, but the methods you will choose, the methods I will choose will depend upon what is my application. What do I want to do? Do I want to classify? Do I want to find out regression analysis, or I just want to cluster the results? I'm making a recommendation model, or is it a chatbot? So whatever is the application, depending on that is what we will be making the model with. So if you will look at this, and I'm not going to be going into all the details, but I thought it is interesting to bring this out, because though the machine learning is basically classified into supervised, unsupervised, and there is also the reinforcement learning. If you will look at the chart here, each of the chart has the neural network as the core, or it is a fundamental, or it's a very advanced method in order to do any kind of machine learning model. Whether it is classification or regression or clustering, whatever it is, the neural network is a must. So it is something which the AI is taking in its direction into, and that is why when we looked at that whole picture of AI, you saw the AI, and then you saw the ML, the machine learning, and the neural network was the subset of the machine learning. Having said that, how do I really look at it? So we can, I like this picture, and that's why I picked it up. It's like the artificial intelligence, and then I have the machine learning as a subset of it, the deep learning, which is a subset of machine learning, and the neural network, which I would say forms the heart of all this. So multiple neural networks combined together forms a deep learning. The deep learning algorithm gives me a machine learning model, and the machine learning model with all other pre-processing, feature extraction, and all other information gathered per domain gives the artificial intelligence, if that makes it clear. So this is where we are going to be looking into neural networks, because nowadays, most of the machine learning models, or most of the AI applications, you will see using the neural networks. So what is a neural network? From where did they get this idea? And of course, they got the idea from human neurons. Whether an AI is being trained to recognize cats or dogs or whatever, it all starts with the neural network, and they've tried to mimic what is the neural network of human neurons. So the human brain is exceptionally complex, and it's quite, it is like 100 billion mini computers working inside this brain. And so this brain, the human brain has a concept of neurons, and I've shown an example or a picture of a neuron, and the neuron has different parts in it. Why I'm bringing it, of course, I'm not talking about biology here, but I wanted to relate this to what the neural network of artificial intelligence is trying to do. So if you will look at the human neurons, it has the dendrites and the axon. And the dendrites, if you look at the tip of it, if I will show with my mouse, if you look at the tip of it, these are the areas which will receive messages or collect messages from other cells. And then it passes on through this axon, and then it is terminated, or it continues. So this is just one diagram of a human neuron, and our brains have 100 billion of it together. So each neuron, now each of this neuron may have about 50 such dendrites, which are the termination ends, and each dendrite will be getting its input from others. Now, if you will look at it, how artificial intelligence had tried to mimic, of course, not researchers say, and medical science knows that very well, not even 10% of the human brain complexity is yet revealed to mankind. But out of the little that has been revealed is what has been taken to mimic artificial intelligence. So how is it done? So how it is done is, we are having the small little human neuron here on one side. So I get the information from all these dendrites, and then it is passed on through the axon, and then it goes to bring the output at the other end. Okay, so if this is how one single human neuron work, scientists said, okay, let's mimic this, and then make an artificial neuron, which will have inputs like the dendrites get their inputs. We will have the inputs, and the inputs would be weighted, and then they will be summed together to give me a function or a model, which will give me some evaluation. And I want to show a video because I don't want to go into the details of the level of math here, but I felt that this video would be self-explanatory in terms of how they try to relate the human neurons with the artificial neurons. Can you see the video?
Yes.
Okay.
This is a simulation of a single biological neuron. Information flows in, is processed by the neuron, and the results flow out. This gives the neuron its abilities to react based on previously learned patterns. Technology duplicates this by creating a structure that processes information like a biological neuron does, except this process is mathematical instead. Just like the biological neuron, information flows in, is processed by the artificial neuron, and the results flow out. This single process becomes a mathematical formula that can be used for simple problems. For those that are mathematically inclined, this will look similar to a polynomial. A polynomial is limited to the problems it can solve for, as shown in this graph of an order 5 polynomial. If this is all artificial intelligence could do, it wouldn't be much use. As with the brain, artificial neural networks' power is in connecting sets of neurons together in layers. When you connect them in layers, the mathematical formula becomes something like a multi-dimensional polynomial. This allows complex problems, like what is shown in this graph, to be discovered and used for our benefit. As before, information flows in and results flow out. But this time, the input to the second layer is from the output of the first layer. The exact steps for a single layer are simply repeated for each layer of the neural network.
Okay, so I thought that was a very good video about how beautifully it shows the relation of the human neurons and how it is trying to be mimicked into an artificial neuron. So all these X inputs are coming from the different data that is being fed to the model. The data could be from anywhere. It could be data from sensors. It could be the data from medical images which are stored. It can be data from the environment. It can be data from, depending upon the type of application. But we saw that there are layers and levels of that the neural activity passes through. And every time it goes through a level or a layer, it is changing and it is diminishing in size so that the output is now more and more efficient. So why do we need so many layers, and why do we need to pass it through so many layers? For example, it's actually going through one layer, and then the signals which are received, they are finding resemblance and then making a new model and then catching up with the second layer. And every time the weights are changed based on what needs to be more weighed than the other not so important inputs, and then to become more and more concrete and clear in terms of the resultant output. So if I have this kind of picture which is fed to the model is going to be taught, for example, to label or to find out the object of cat. So if this is what is being fed, it will pass through different layers. These are called as neural networks, multi-layer neural networks. And you will see that the dimension of it is reducing until we come up with something which is more concrete and having high efficiency. So this is one more video I would like to show you how actually this interaction happens. And this interaction, which is hidden, we will not be able to see the layers which are in between. So if you will look at the video, it's showing you that as an object of a cat is shown, there are interactions happening and becoming more and more concrete and resulting to that, okay, the output is a cat and not a dog. So in order to have all cases considered and in order to have efficiency which is much higher, we will need to have multi-layer of neural networks. So that's about the very core or the base of what the artificial intelligence is, how machine learning is the subset of it, and how neural network is a subset of machine learning. As I told you, how smart is AI and what is the direction we are heading to? We are heading to a direction of involving cognition. When I talk about cognition, this is natural to humans. It is something which we sense from different sensory parts in our body, and we gather the information from multiple domains. There is a context to every decision which we make. For example, we get some information today, and then we get some more information maybe from a different domain or tomorrow. Then we as humans have the ability to piece all those information and come up with that, oh, okay, I get it now. Now this is how, this is the meaning of it, or this is the answer to it, or whatever. But machines are highly limited in this ability of cognition. They don't have this capacity of getting anything from other context or other domain unless they are taught, unless they are fed, or unless they are given that information. And that is where cognitive AI or cognition technologies will help. So what are these cognition technologies that are being taught with the artificial intelligence model so that we come up with an AI which is close to mimicking a human? There are so many different types of technologies, which are cognitive technologies, which are coming up. And some of them which are shown in this picture are the computer vision. A lot of images which are fed into the computer to make a concrete decision. Machine learning, of course, the natural language processing, the text processing, which are usually used by the chat box and the assistant, the virtual assistants. Optimization, there are a lot of constraints on which they are working. So how do we really get an efficiency of a good enough efficiency, still working in a constrained environment? So that is a whole new evolution which is taken into account. background, then speech recognition, robotics. So all these areas mixed together, we can have the cognitive technologies as products of the field of artificial intelligence. So what am I saying is, while we have the big picture of AI and the ML and the neural network, cognition is the area of evolution which is going to be integrated into the AI, and that has so many different fields associated with it. So in short, if I would want to say that AI is not something which is by itself, I can say, okay, computer science is the field, or programming is a field. It is a field which involves knowledge and understanding from multiple different domains. It is a field which needs knowledge from algebra, from programming, from calculus, of course, a knowledge of the big data, the amount of data we are coming to. Trillions of data are coming every second. The domain-specific knowledge, if I'm building artificial intelligence for healthcare, maybe for a breast cancer detection, I need to know exactly what are the features that can be called as benign, what are the features that can be called as malignant, and how do I define all those domains? And I also need to have an understanding of statistics. So that is a combination of a whole lot of different areas which are coming together in order to produce or develop an artificial intelligence model. And that is why we see artificial intelligence, it is having so much of a complexity around it. And so somebody wouldn't just jump in to start to make a model right away. And hence, there are so many frameworks and services just to ensure that people get some exposure and knowledge and start building their AI models by themselves. So there are some AI frameworks, and there are also services that are available which are ready to use frameworks. So you don't have to start from the scratch. Some of the frameworks are built, some of the libraries are built, and then you can just go into there and build the application based on the framework. So one such framework which I would like to show is the TensorFlow. Just to show you, if you will develop an interest, how to start and where do I start. So a TensorFlow is giving you a start to finish framework. So if we are not very good in programming, not all of us are very good in all of those areas. So I'm not very good in math, for example. I'm not very good in something else, but TensorFlow gives an end-to-end open source machine learning platform. So you can develop a basic, very basic artificial intelligence model using these free open source frameworks which are available, and it takes you through the process, and it will help you to make a model for your domain or for my domain which I'm building it. Having said that, there are also applications available. So I've just listed some of the frameworks. I'm not going to show all of them, but there is this TensorFlow, which is really very well used with the scientists and the researchers, the Caffe, the Microsoft Cognitive Toolkit, the Torch and Chainer, and so on. There are also services which are available, and these services are artificial intelligence as a service. They are sometimes called as AI, AAS, or they are sometimes called as MLAS, AAS, like the machine learning as a service. So what is this, like AI as a service or ML as a service? They will provide, or they offer a range of services which are already available as part of the cloud computing. And there are these Microsoft, IBM, I've worked a little bit with IBM, Microsoft, IBM, Amazon, Google. They provide the services. So the main advantage of this ready-made services are that customer can get started quickly with making a machine learning model without downloading any specific software, and they can build a decent enough machine learning model without a lot of pre-learning to be done. So that is the advantage. So there is a lot which is created so that just to boost the use of AI among the people. So as we are heading into the time, we are heading, as I showed you the graph in the beginning, we are heading into a trajectory which is really exponential. I would say that it is one of the industrial revolutions that we are going into. And so everybody wants to make sure that the team, that we are ready for what we are going into. Now so that was about the software part. When we're talking about AI, it's not just talking about small data. Now these data are immense, they are humongous. And so we also need, good enough hardware to support. And therefore we have to be going in from a series from our normal CPU-based machines into the graphical processing, which are basically used for gaming and fiction and AR, VR kind of applications, into maybe FPGA, field programmable gate arrays. So they are specifically meant for some logical processing early. And then there are these advancements in the hardware, which are very specific. The ASICs, the application specific integrated circuits, these are very specific hardwares which are built so that they have very high capacity of computational processing capacity to handle this amount of data which is coming into the model of the artificial intelligence. And of course, quantum computing is going to change all of it. Quantum computing is for all of these, like the CPUs, FPGAs, the ASCIIs, we're talking about bits, we are talking about a 0 and a 1, but quantum computing, we're talking about qubits, we are talking about in a globe, if I can have just 0 and 1 as two positions of the bit, with qubits, I can have n number of positions. And that is how the speed, the computational processing speed is going to revolutionize. And that is going to change the whole story where we are advancing into. So application of AI is everywhere. And we just saw a few of them, and it is in recommendation engines, whether you are going for shopping, whether you have been Googling and finding out some of this, and then on your sidebar, you can see similar such products being displayed. It is in social media, it is there in chat box, it is there in healthcare, it's there in security and surveillance, and everywhere, whatever be the type of application. I wanted to show a small video again on how AI is really well built by Wemos with the autonomous vehicles. So I'll just click this to show you.
Back in 2009, in our early days at Google, we started working on self-driving cars. Today, we're called Waymo, and our fully self-driving cars are on the road. They use a range of technology we've built from the ground up to understand the world around them and get you where you need to go. You're about to see how it all works and what it feels like to ride in our car. As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed. And high-resolution cameras detect visual information, like whether a traffic signal is red or green. It then combines all that data to understand the world around it. For example, in this fraction of a second, it knows exactly where it is on the road. It can also identify everything around it in full 360 degrees, and then predict what those things might do next. And it doesn't just do that for the objects you and I can see. It can do that for things up to 3 football fields away. What makes everything you can see right now possible is experience. Waymo has already self-driven millions of miles on complicated city streets, and it's constantly learning from every single mile it drives. With all that knowledge, it can plan a safe path ahead. In this instance, giving that cyclist enough room to cycle past us, and also looking out for that pedestrian on the sidewalk. And when it comes to making decisions, this is a good example of how Waymo doesn't just take into account your safety. It also makes sure that both you and the people around you feel secure and at ease. So now that you know how Waymo works, it's time to take your first ride in one of our cars. Take a look around. You're now riding in a fully self-driving car. Some things might immediately stand out. The fact that there's no one in the driver's seat, no one turning the wheel, and the screens, which show you what the car is seeing and the route it's taking. But you might also notice that the ride feels a lot like being driven in a regular car. And that's the way it should feel. All this technology, which allows Waymo to see, identify, predict, and plan, should make an extraordinary ride feel completely ordinary and create a very normal journey that simply gets you from A to B, safe and sound. And while it does all that, all you have to do is sit back, relax, and enjoy the ride.
So that was a nice video. I thought about how AI was used in self-driving cars, and it's used almost in every field. So I have put some pictures to show how it's used in virtual assistant or chat box for in Siri, Alexa, and these ones we know most of us must be having them in our homes. They are also used in agricultural sector for autonomous tractors and drones to enhance the productivity of crop yield of farms. They are used in commerce, where you want to be looking into your stock or inventory. So AI can be used for proper management of the inventory. Autonomous robots are handling the inventory of performing various difficult and tedious tasks like decision-making tasks. And of course, AI is used in healthcare and medical image processing and analysis. The way AI is growing in healthcare is unparalleled. It's really developing a lot of models for clustering, for classification, for recommendation, for analysis. And recently, I also came to know that AI is also being used in law. They're providing additional insights and shortcuts through analytics. So because the vocabulary the lawyers use and their wordings and their laws are written so tight, and it's very important and very difficult for them to have a database. So through AI analytics, automative creative process, they are including this AI-based tool in some of the legal work. So that's something I came to know. That was new to me, but it's almost everywhere. And if you will see the Gartner report, he says that there is about 37% of organizations have implemented AI in some form or the other. And AI grew 270% in the last 4 years and has tripled in the past 1 year. So that is a really big number for what we are seeing. And the impacts of AI in healthcare is what I'm going to be talking for a little bit of time I have. So AI is used in the healthcare, especially to better organize healthcare logistics. It's something like you are going to suppose if you have a blood test, so you are giving your blood you're taking the blood and the pathologists take the blood and it is being sent somewhere, and then you get the results of the blood work, a whole lot of numbers, which is just makes sense to the doctors, but then that is what comes out of the blood sample which you have provided. So with the data fed into the machine learning model, we're going to get a whole set of insight of how that data repository can be used for now and for the future. So that is what is one of the major change which is going to happen in healthcare. Of course, boosting drug design to a new level can be done with AI, improving work conditions for medical professionals, because with the AI recommendation systems or with the AI models, there can be ease for the medical professionals in terms of attending the more serious cases, as we saw that COVID AI-based tool, because of what the time. So what we are going into a time, into a season or into a era that is, the demand is so high, but the amount of hours is still the same. And the amount of hours being the same with the high demand, we need to be taking into advantage of the AI models. Now, I've worked into some of the AI applications with the new associations between risks and diseases. So how to identify if a patient is at risk or is prone to having something which is similar to whatever is the analysis. Maybe it is a seizure detection, maybe it's a cancer detection. So how do we analyze the risk of certain diseases? I have some experience working on that, made a couple of models in different applications here and in my previous work. AI is also used to help forecast future outbreaks and pandemics, and we saw that today in our slides before, how we could use. So the data which was stored in the month of March was used to make a triage system with AI-based tool, so that could help the hotline people to, and that would really helped in providing good advices to get an unbeatable specific data-oriented task, and also to provide patient data as precision programming. I'm going to be just talking about couple of experiences I have had with AI, especially in the healthcare. So I have been working with a machine learning model, especially for the neonatals and with fetal movements with biosignals for neonates, and different types of biosignals like the EEG, the ECG, the electroencephalogram, the electrocardiogram, the heart rate variability, these kind of biosignals. We tried to collect them to extract some features because of especially for the neonates, because they are very vulnerable and at high risk. So what we did with these signals, and this was in association with Queensland University of Technology, Australia, Brisbane. So what we had a whole repository of biosignals which were provided to us. So what we did was we had to first do the feature extraction and classification of them. And when we used some digital signal processing techniques to come up with an SVM model, a machine learning model, a support vector machine model for analyzing and for classifying those signals. So that we did with the neonates. We also took some fetal movements, and we have done some classifications on that. So the time frequency domain analysis, which is a mixture of a time domain and a frequency domain. So anytime when we are doing some analysis on the data, we are either specifically looking at one of the domains, but this one took both of it into consideration to do the extraction of the features. So that is some things which we did. And another project which I worked here at Mohawk was on seizure detection. So in this project, what we had was we had data from different sensors. So they were IoT sensors, and we collected data from the different sensors. And these data were, we did not have a huge repository of data like the previous project for this one, because these data were collected with clinical trials. So for every clinical trial, we need to have approval, we need to have permission, and we need to have patients which have seizures. So we did not have a major data bank to actually do a whole lot of machine learning model, but with the data we collected, of what I worked with the Watson's, with the IBM Watson's SPM, the linear regression model, to come up with a model which could help to identify, is the patient at risk for seizure or not at risk for seizure. So these are some of the works which I've done. There are other works which I've done, was just to make a classification of ECG signals, and all of them were with supervised machine learning models. So in the beginning, I showed you there are so many different types of machine learning models. So I've basically worked on the supervised machine learning classification kind of model. So how is AI going to go forward? AI is going to be reshaping the future, is what this market news is saying us. It's going into every area in manufacturing, healthcare, and it gives a percentage on every area where it is going to revolutionize. And I'm sure we know by now that it is everywhere, and that is how it's going forward. IBM has committed about $1 billion to commercializing Watson. Similarly, Google has made major investments in AI, and Facebook has made major investments in AI too. So AI is going to dominate the world, is what some of the politicians are saying. Like Putin says that AI will be dominating the future. I'm not sure about that, but that is how it is going ahead. When we have such a major breakthrough technologies, of course, it comes with challenges, and of course, it comes with a lot of things which we have to be careful about. And one such greatest challenge about AI is security and privacy and trust. How do I trust these systems, and how much do I trust the system? So that is one area of research actually I'm working on in my PhD thesis. Yes, I have all these autonomous systems, but especially in healthcare, when I'm giving all my biosignals, my very personal and private information, how much do I trust the system? And that is one of the major challenges with which scientists and researchers are trying to figure out. How can we really have a trusty or a trustworthy AI model? There are other challenges also on the bias of the data and the knowledge and the computing power. With the quantum coming in, maybe that is going to go off, but these are some of the AI challenges currently. That's all for now, and thank you all for listening, and I'm open to any questions you may have.
Minnie, thank you. That was absolutely amazing. And I do have a question.
Yes.
So I am the furthest away from an expert, so like 180 degrees away from you. And I have to tell you, that was a wonderful way of explaining AI to someone who really doesn't know AI. Your level of knowledge and the way you can actually translate it from how to bring it forward to someone at my particular level and still communicate at that level is beyond impressive. One thing that I was wondering when you talked about the frameworks that currently exist, who uses those frameworks and who has access to them? Are they locked? Are they secure? Can anybody go on? What would be the application and who would use a framework?
Yeah, so anyone who wants to develop a simple, modest, decent ANI, artificial narrow intelligence, can use those frameworks. They are open source, they are freely available, and they are developed by these giants who are already working on AI. And it is one of the major objectives of providing the frameworks and services is to boost AI in usage, because that that is where scientists have noted that we lack, where we are, as technology is developing and it's advancing, but the workforce who uses this has to be also getting some opportunity to work on it. So they are totally free. They are developed to have an end-to-end experience. And I have worked with one of them, not sometime near, but I think a couple of months before, and it takes you through a process with so many inbuilt libraries and functions and steps, because the whole AI journey would have something called as pre-processing, of course, the data collection, and then the feature extraction and the pre-processing, even before you can sit and think which machine learning model you want to use. So all that, it takes you through stages. It takes you step by step.
So Minnie, I have a question. And again, I joined a little late, but I need to sincerely thank Minnie for her time here today. We're very lucky to have her on my team and as part of my staff. Minnie, I was just wondering if you could share, and I apologize if I missed it at the earlier time, but for young people who are considering different possible career paths, what are the subjects or the things in school that they should be focused on while they're studying in high school, so that they put themselves in a good position to be able to take advantage of some of these opportunities once they get to college or university?
Yeah, so let me just... I had a slide. I'm just going to try to go back to it. So a slide which was showing, so math, so the couple of different things that the AI field would like students to take is, one of them is math, one is, so it's a subset of computer science. Let me just grab that slide list, please. Okay. Can you see that? Okay, so it has, so something which an AI is built around, and not everyone would be an expert in all of them, but at least the basic skills would be programming and math. So what these two, like the domain specific knowledge would be very specific to the application, but it is something which needs a very high level of math, especially into the regression, calculus, and linear algebra, and also some basic programming skills. It may be in whatever kind of programming, but most of the services and frameworks which are available have very detailed inbuilt libraries where you don't have to literally program, but a basic knowledge of programming with a knowledge of math would be really good for those who are in schools.
So we're talking about programming, we're talking about vectors and functions, we're talking about data science courses that they'd be getting in the high schools. Yeah, thank you.
Welcome.
It's remarkable, and I just wanted to say, I'm sure you'll have the same experience 10 years after your PhD, but when I think about doing some of the things I was doing in industry about 10 years ago, it's so crazy to think about how far we've come with this, you know, in such a short period of time. So I know that for some people it may feel still a little bit like science fiction, but it's just when you start to see what's actually in use right now with the Google cars, for example, you know, we're getting 5G networks in Hamilton. We're going to be in a position where we're going to start seeing some of this stuff on our city streets and start seeing this used widely in our hospitals and in our culture. So it's a really neat time for students. And, you know, the other cool thing about these technologies is, while it might be something that Minnie's learning in her PhD right now, I guarantee you we're going to have ways for you to learn and to interact with us in very real ways in the next 4 years. We need more people in this field. And so with all of these frameworks come opportunities for people to focus on one area and not have to be an expert in all of these areas. And that's the kind of cool thing about it, is we get to work with a lot of different people. And, you know, also kind of pulling it back to women in tech, you know, we see a lot of people who enter the workforce who really want to make a meaningful difference on the psychology and the ability of people to feel empowered with new technology. And Minnie, you've talked about a lot of different things, but I'm sure you can speak a little bit to that about how some of these tools really enable us to make much better decisions that have an impact on human life, right?
Yes. Like most of them, I feel are interconnected somewhat. Like I feel that, okay, if I'm talking about AI and then the technology of IoT and then the technology of robotics, all of them, for me, it looks like interconnected. And then all these advanced emerging technologies, how they are really used in the field, in the application, is totally mostly based on the domain we are talking about. What is the application area? What is the domain that we are talking about? But for me, AI and IoT and robotics and all of them are like, the data comes from sensors. The sensors are IoT, and then we make the robot move according to the vision. So vision is another emerging technology. So it's all like...
It all works together, right? Yeah.
Yeah. But as you said, Liz, you don't have to be an expert in all of them. That's the beauty of it. You can be an expert in one, and in one you can be an expert in one subdomain and still be doing a lot, because there is it's so huge.
Were there any other questions? I saw one of our participants wrote in that they see the value in the high school classes. Absolutely. Well, thanks again, Minnie. And I know will be many more people who have an opportunity to view this material and get some introductory exposure to all of the different great AI information that you've provided to us. It's really great to see the whole landscape and the way it all comes together. And I certainly learned a lot from the presentation today, and I'm sure that all of the participants have as well. So once again, thank you so much for your time, and it's been really nice getting to see how things have evolved in the last little while here.
Thank you, Liz. Thank you. Thank you, Rebecca. Thank you, everyone.